Okay, since I have not been given an introduction, maybe I can introduce myself. So I am Thilakavathi Sankaran, and I am a business intelligence and data analytics professional. So I have over 16 years of experience in the industry. I have worked across like many different industries like the retail, the entertainment, the healthcare, and so on. I have some of the research done on the data analytics side, and I have some papers that's been already published as well. So today, it's my pleasure to be here at the ICCNet, 2025 conference. I'm going to talk about something that's becoming um, the heartbeat of the modern infrastructure, about the networks itself. So it is about the data analytics, how we're going to, infuse that within the networks. So, and it's how it is redefining the network design, the performance, and the decision making. So we are all living in a world like where the networks are invisible, but still it's indispensable. And the way that we manage them must evolve as fast as the data they carry. So we know that everything has been captured as a data, like everything, whatever we do, and everything has been, transferred through the network, and everything is like a data itself. So that's my topic about like, how we're going to implement data analytics with the networks itself. Okay. So the importance of networks today. So think about it, like, so every time you stream a movie, you join a Zoom call, or you check your health tracker, or even, when you break the cars, like, for your autonomous car brakes, everything is like within the network. So the network is making that possible. So networks are no longer, it's not like, how we see them as a static infrastructure. They are actually dynamic, real-time ecosystems, and that support like, billions of users and the trillions of events every day that's happening. And as the volume, the variety, and the velocity of the data grows, managing these networks using traditional manual methods is simply not enough. And we're all sure, like, so many of them actually talked about the AI. So we're all aware, like, where we are heading towards. So, and as the volume, the variety, and the velocity is growing, like the traditional methods is no longer enough. So we are going to move into something different. So what are we going to do? So how do we keep the networks agile, efficient, and intelligent? It's the answer lies in the data analytics. Since I'm from the data background, I'm just going to talk about like, how the data analytics works. So the data in networks, a vast resource. Networks constantly generate rich data, the packet flows, the device health metrics, application usage patterns, the latency, the jitter, the congestion events, and of course the security logs. So in the past, this data was underutilized. So how many of us just store the logs and then you don't even take a look at that unless something goes wrong and you actually wanted to dig deeper into it. So the logs were stored, reviewed manually, and then discarded, or nothing, no action has been taken. But now, with the cloud computing, the AI, and the scalable platforms, we can actually turn this raw data into something that's really useful and into a real-time insight. So for example, like, the AT&T's analytics platforms processes more than 590 petabytes of data per day. That is really, really huge. So what they do is like they identify the anomalies, predicting the condition, and rerouting the traffic automatically. How cool is that? So this is not just the efficiency, it is actually a shift from the reactive to the predictive network operations. So the key applications of data analytics in networks. So let's explore the four powerful applications of analytics in network environment. The number one is the traffic analysis and the optimization. So using the real-time telemetry and the historical trends, analytic tools identify the bottlenecks and dynamically reroute the traffic. Just think of yourself like you're driving on a street and the Google Maps gives you the directions like when you even go on a wrong route, right? So just like that. So this reduces the latency, prevents congestion, and ensures the better bandwidth distribution. Next comes the predictive maintenance. Analytics identifies hardware showing early signs of failure. based on the temperature, error logs, or even the power usage. So it's not only within the, the networking side, even on the healthcare side, like, the predictive analytics is actually doing really, really well, and everybody is looking forward to it. So companies like, Cisco use the machine language models to replace devices before they crash so that they could avoid the costly outages. The third comes the security and the anomaly detection. Machine learning models actually analyze the traffic behavior, comparing it to the established baselines. So we heard a lot about the machine learning sometime back about the LLMs being trained with the data, different sets of data that's been provided, and it gives out the results based on how we train the LLM. So similarly, it can actually detect the anomalies, like if there is going to be a sudden spike in the outbound traffic from one device, it can instantly flag a potential attack or a malware infection. The last one is the enhancing the user experience. This is the real important one because it directly connects with the user itself. Data from user sessions helps networks prioritize mission critical tasks. For example, a hospital's real-time monitoring data can be prioritized over someone downloading a movie. This adaptive quality of service keeps users happy and systems safe. So whenever the user is happy, everything is going to be happy. So we all have experienced the Zoom. Suddenly, when you're on a call, it suddenly drops the quality. And we've all experienced that. So what is actually happening behind that Zoom drop? That's a network trying and sometimes even failing to adapt without the help of real-time analytics. So that's what, Zoom should actually adopt the data analytics practices and try to improve itself over time to avoid these kind of outages. So the emerging trends in network data analytics. So we're just getting started. So as I said, as everybody said, the AI is just, emerging, or it's just an evolving technology. So we are at the beginning of it. There is so much to go beyond this. So look ahead and, let's see what is actually reshaping this landscape. The AI-driven automation. We are seeing zero touch networks. When I say zero touch, it means zero human intervention, where AI not only predicts the problems, but it also tries to resolve them automatically. Example could be Juniper's Mist AI platform is one such tool. It actually diagnoses and fixes the Wi-Fi issues without even a human intervention. Next comes the edge analytics. With billions of IoT devices, analyzing data at the source is critical. Edge analytics reduces latency and cloud dependency, enabling real-time decisions such as traffic signals, adjusting to current congestion in smart cities. Cloud and big data integration. Of course, we talked about the data, and there's going to be trillions of set of data every day with all the events that's happening around us. So it's actually going to be a big data integration. So the cloud native analytic platforms like the Google BigQuery or the Azure Synapse allows massive data sets to be processed instantly, turning multi-gigabyte flow data into visual dashboards within seconds. That is really cool. Just imagine with all the data that you have, and if you're able to produce a dashboard within seconds, that's going to be awesome. Companies would love that. So now we talked about all the good things of all this, the AI, the data analytics and stuff. But again, all good things do have some bad things within them. So what are the challenges? So the data privacy and governance. So we talked a lot about that in the previous sessions. Everybody talked about it. AI is, lacks the privacy. So when there is more data, it means we are at more risk. As analytics gets deeper, compliance with the HIPAA or the GDPR or other privacy regulations, it becomes critical. So we must balance the insight with ethics. Just getting the dashboard in seconds is not going to resolve your issue. You should also maintain the privacy of the data. You should know with whom you're sharing your data with and what your LLM is trained on. Next comes the scalability. The speed and volume of data require high performance data pipelines and distributed storage systems. Like I said, there's going to be like trillions and trillions, I mean, gigabytes or petabytes or whatever, it's going to be huge. The data system is going to be huge. In order to transport those data in the networks, we actually need the high performance data pipelines and also the distributed storage system where the data can actually be stored, and the the dashboards or reports where the decisions can be rightly taken. You need the right architecture or your analytics platform becomes a bottleneck. Yeah. I mean, even the previous speaker spoke about it. So that's a really good point. It's again a repeating one, but I can't help it. It's the same thing. It's all about AI. And the next thing is the talent gap. Again, there is a skill shortage. We know, people are specifically specialized in data science, or maybe they are an expertise in, network engineering. We can't find people like where they are good in both the things, like, the data science as well as the network engineering. So that's going to be something like, the shortage of the skills, like where people know both the sides of it. So we need people who actually understand both the networks as well as the data science. So what's going to happen is like, we are going to introduce a cross-functional team culture. Maybe like, combining the system administrator, data engineers, and AI specialists together, and all of them work together to get into better product. So that's where the talent gap is. So now we talked about the good, the bad, and what is the future of it. So the future is like, self-learning. I said like the networks of the future will be self-learning, self-healing, and self-optimizing. So the goal is like, it's going to be like zero human intervention. Like everything is going to be automated and everything is going to be done automatically, and everything is self without anybody interrupting it. So we are talking about the intent-based networking, where the business goal is like, say suppose like they wanted like 99.99% of the uptime. So that means like there should be no outages. So automatically it should configure the network behavior using some kind of the AI driven logic so that it can maintain the 99.99% uptime. These networks will also play a key role in sustainability, meaning like they reduce the energy by optimizing the routing, like shutting down the unused paths or shifting compute workloads based on the carbon footprint. So where are we going to use all of them? Like, the 6G, the smart cities, and autonomous mobility all rely on this vision. So the future itself is going to be dependent on the AI. So to wrap up, I just wanted to highlight a few points. So data analytics is no longer optional. It's not like you can just ignore the data scientists and the data engineers. We all need to work together. Network engineers should also work with data engineers to get into data analytics. It is mission critical to the way that networks operate. From performance optimization to security, from maintenance to user personalization, analytics is the common thread. Like everybody needs data to read them, not just to store them. But we must adopt it with intention, like, protecting the privacy, scaling it wisely, and developing the right skills. So I challenge you today as technologists, researchers, and leaders right here. Let's not just connect the world, let's build the networks that actually think, adapt, and elevate how we look and work. Thank you so much for this opportunity. Thank you.
Thank you, Ms. Thilakavathi Sankaran, for your insightful presentation. Your talk on harnessing data analytics to transform computing and communication networks offered valuable perspective on driving smarter, data-driven systems. We truly appreciate your contribution to ICCCNet 2025.